Sabemos que el sábado por la mañana es un día
Right, we know that Saturday morning is a difficult day. So how many of you
got a problem that I can't fix.
last night? Alright, I guess that those who went are still sleeping. So we found this out. As well as the West Coast. So
Got a problem that I can't fix. Cause I can do it in the mix.
so there is still time for you
Got a problem that I can't fix.
So, those of you who don't know me, I like revenge, so I live there,
Got a problem that I can't fix.
so thank you very much.
Cause I can do it in the mix.
I'd like to start the day by thanking our sponsors. Thank you very much to Microsoft. They have sponsored this.
Got a problem that I can't fix.
Sponsored us, but has helped us with other things. They also have t-shirts. Some of you already done t-shirts. So
Got a problem that I can't fix. Cause I can do it
from Israel.
in the mix.
So yesterday we had exploiting, researching vulnerabilities. They want to set up a hub here, and it's also very, very important. We all know that there are mafias and brokers out there offering you 100K, 200K for vulnerability. That's good money, and we all understand that after researching something for 3 months and getting an explode, getting reasonable money for it could be a good thing, but do not sell it to someone with a strange Russian accent. So you better sell it to a good broker. Then Telefonica, 11 Paths, they have always been with us. And then Checkpoint people, they organized a contest and they gave away a drone. So CNZ, which is a platinum sponsor, they sponsor Madrid and Valencia conference. And this is very good for us because we are not, again, fighting really hard to get budget for Valencia. Thank you very much to them. They've been with us since day one. Our silver sponsors, ThatLogic, Blue Leaf, Hack Labs, and S21. Well, yesterday I heard that, well, I was talking to a person, and I was talking to this girl, and she said my alias is this, and hers was that. So apparently, well, we've known each other since 1995 without knowing that, and she works at iHack Labs. So ThatLogic, they are part of our family, the same as Blue Leaf, and S21. This is the first time that they are sponsoring us. Corey, remember, voting system this year is done through Corey. You have to go to the website. With this address, https. Then you enter your phone number. You will get a text message of confirmation. Then you validate your phone, and then you enter discount voucher, route 17. If you don't input the coupon, it will go against your balance. So I'll show you what are the results so far. So this is the address, URL, and this is the the results so far. So also very important, it may be the case that one of the days of the event, for instance, yesterday or the day before yesterday, imagine that you didn't like one of the presentations and you want the speaker to, I don't know, to know about that. So they are considering, current people are considering how you can cast a negative vote. Yeah, we really want to be hard. So we want to keep up a high standard. So this is a progress of the voting. From the balance, you can see the level of assessment. So please support Curry, Spanish startup. They are doing very well in terms of microtransactions. It is a Spanish startup. It is very important that we support our projects, and these people are doing very well in China, Singapore, etc. And they've been working a lot with Telefonica recently. So now I'd like to give the floor to two speakers which are completely unknown to us. So the organizer of a small event, Blue Knife, was that the name of it? All right, so would you please introduce yourselves? Thank you very much, Roman. Hello, good morning. Well, speaking to an audience, it's a bit frightening. Well, Roberto and Daniel, with you. So Roman sounds like a member of Russian mafia. And okay, and what he said about the negative votes. Right, okay, we'd like to apologize beforehand because we say lots of swear words. So we will be talking about Docker today. Despite what Jaime mentioned yesterday about Docker, Docker is not as bad, it's not a silver bullet either. And what are we going to refer to? Well, we have carried out a research, we have broken it down, we have logged the images, and well, these are a few things that I'd like to share with you. We liked it. A bit of spam about ourselves. Robin insisted a lot in me showing this to you. So these are us. And now, well, my presentations, the slides are in English. Probably there will be spelling mistakes and other type of mistakes. So first of all, we'll tell you about what's Docker about. Then we will move on to the Docker environment. We will also tell you about an environment for continuous integration, and then we will dissect Docker images. We are going to abuse Docker registry. So we will be focusing on points number 4 and 5. So Robert, take over, please. So mandatory introduction, what's Docker about? I want to repeat some of the things you are already aware of because you know Docker, you use Docker. So Docker is a container manager. It allows us to manage the creation of images of our software. It also gives us means to deploy these images in the systems where we want to run them, execute them, and we can also execute those images with some levels of or layers of insulation, so to speak. So when we talk about that insulation, so the question is, what is the relationship between Docker and virtual machines? So Jaime stepped a bit on our presentation yesterday. So for this management, Docker uses the M-space kernels. These are abstractions of global resources of the system that can be attributed to processes, so that from the viewpoints of those processes, those resources look like if they were your own. I don't know whether you have executed Docker. If you make a PS, you only see the processes of the container. So if you do fconfig, you will see only some interfaces, and if you go more when you execute databases that working with your IPC regions, these are the kernel. And that sensation of isolation that you get because you cannot see other things in the system could be a bit misleading, because you are there, you said this looks like a virtual machine, but it is not a virtual machine. Why not? Because a VM has its own operating system, its own kernel, and then a hypervisor with virtual devices. But Docker is an application executing other application and assigning processes to them. Therefore, the process within the container interacts with the OS, same as any other process outside another container. So therefore, as Jaime said, kernel unit is as much as I need to be in the Docker host. Docker is not virtualization. We just wanted to clarify that for you. Someone said that yesterday, and this is an important point to make, because we work in security and we should bear this in mind. Virtualization should continue to be there, and Docker is just one more layer that helps us do a number of things. Right? We said that this is a CH root with asteroids. So Docker has done what we could have done many years ago, but now we can do that. You can do exactly the same thing, but in a nicer manner. How are these images built? Docker has files known as Docker files, where the definitions, the skeleton of the image that we want to create. For instance, a Docker file there is based on an image that Python has. I guess that Ubuntu is the same. And here we define that we are the maintainer, and then we install all these packages, and then we say when the image is run, the first command to be executed should be Python 1. When we execute a Docker file, the first thing that we execute is an image. All right. When you execute Docker build, you execute the image, you generate the image, packaged image. We'll tell you more about the image, technically speaking. And then when we execute these images, we have the container. So that is to say the image instanced in an execution. To summarize, Docker file is the skeleton. When we do the Docker build, that goes through production area. We create the images. The images are executed. As they are being executed, they start to be full of logs, etc. And they are different by similar, same as this corn. And this is in as much as you need to know to understand what our presentation. Well, Docker is made up of several components, so to speak. When we are talking about the execution environment, Docker supports itself in a number of pieces. Therefore, it is not a nonsense software, a single piece of software that we installed and that's it. We have, on the one hand, Docker registry for us to upload our images, as Robert showed you before. We have the Docker orchestrator. We are not going to talk about them because that's a completely different thing. Well, but orchestrators tell us where things go and how they go there. We also have a Docker host. That's where the Docker images are run. Docker host is just the machine, and that's it. And then we have the image builders. Image builders, conceptually speaking, is a piece, but part that could be embedded in another part. We will be focusing primarily on Docker registry. So we will tell you more about continuous integration and continuous deployment. I don't know whether you heard about this. This is very trendy nowadays. And this is one of these difficult definitions that you found on Wikipedia. Well, later on, you read through it. This is the classic life cycle for continuous integration. So this is the classic life cycle of software. This is what we are used to having: requirement, design, implementation, verification, and then some maintenance is done on the software. The problem here is that there is a highly manual process here. You know, these meetings when there are 10 people gathered and people say, are we going to go debug, etc. I don't know whether you think in one of these not effective meetings at all. And then restarting the process is really, really hard. It is like giving birth to a baby. So restarting the process, as I say, is very, very difficult. Sometimes you want to be killed. So if this is a more typical life cycle, so this is a more of a modern environment. So we have the developers, we have managers, we have a system to control versions. We could say that we have an orchestrator, that is to say, or a part or a piece of continuous integration. So basically, developers, for instance, a GitHub. So the concept here is that a developer, as it shows here, bottom right, generates a piece of code, and then that goes to continuous integration, and that goes on the testing, and automatically, then the upgrade, and then it goes back to developers. This is more of a modern life cycle. So I'm not going to tell you about the classical deployments because I just don't have the time of it. But if we mix them both, this is what we have. We have a continuous integration. That's where the code comes out from. And then the orchestrator, it works as a router, builds images, etc. And then the Docker host, where there is a container running, and it has the software running at a given point in time. So we have here, software is generated. So if we have a new release, it goes to production, then we send that out to the orchestrator, and then the orchestrator says, okay, do whatever you have to do. That is automatic, and the developer doesn't really mind what is behind it. It is like magic. It goes to Docker image builder, then you get a new image that goes up to the registry, that is the new release, and then the Docker house says, please upgrade yourself because there is a new software version. Then it downloads the image from the registry, it executes it, and ideally parallel, it works for some time, and the old image is removed, and then it is replaced by the new image. It is very important, and in this very last phase, at no point in time the service is stopped. in theory, this continues, it's all the time in operation. So it is magic, and we all like magic. This is very nice because you can focus on your thing and you don't have to do things that are difficult to do. So now, let us try to dissect Docker images. So I don't know whether you've used Docker before. You go and say, okay, I get an image, I take an image, I upload it, download it. But what's a Docker image? A Docker image is a tar. So I could have shown you a different image, but that's the way that I got. And then you said, okay, it's tar.gc. No, it's only tar. So if you get an image, you rename it, you make it a tar file, that's it. That's the Docker image. So it's a tar.gc. And when you unzip it, it contains number of folders. So there are many things in there. We'll tell you more about them. Okay, you unzip it and that's it. So there are many things in it, but what are we interested in? We have a file with a strange name, which is SHA-256. It has lots of information. However, we are interested in this global meta information about your image. So we are most interested in finding about all the modifications that have been made to that image, and it has the hashes. It also includes the hashes of each layer. What are layers? Layers are these subfolders. As you can see, they are all named. However, the hash in here is the hash of layer.tar. And this is important because when we are talking about global references, it tells us that that is exclusively tar. We also have manifest, also quite important. Therefore, makes a reference to global configuration. We'll see what tags are about. And then it also has a list of layers, a long list of layers. It tells us about the first layer that we will be unzipped to build the image, etc. And now in terms of repositories, again, more references to the actual layer. So this is a long list of references. And then we have all the layers. Each of the layers that are just actually subfiles are always made up of 3 files, a JSON, a layer.tar. The JSON contains meta information about that actual layer, and then the layer.tar, which is the actual content. Also to mention that each of the JSON makes a reference to the parent layer. And there are very nice drawings explaining these references. But this is what makes it difficult to work on an image later on, that is to say, to modify all these references. So this layer references this one and this other one. So, and then on top of that, we have the manifest. So a bit complicated indeed. So these are, each JSON contains the layer metadata, the version, contains the layer version. And same as when you unzip tar, you get an incremental file system. We'll tell you more about it. So this is what we saw before. So we will simulate the extraction of content, because at the end of the day, it's an image. Because when you are within a Docker image, you see a file system. And that's what makes up an incremental file system. So it takes the first layer, and then it takes it to the directory, and we have the first part of the file structure. Same thing for the second layer, and then the last layer. Here we are. So now we have our final structure. So for instance, in a Docker file, if we have defined that we want to base it in the Python image, the Python image has its own layers. And then when we ask it to install things, that layer is working on the previous data, because when you do a Docker build, you are running the image and you are modifying the previous image. And if needed, you get to see the content of the previous layer, right? Yes, important information there. So, and this is the directory we will be working on. So what are you telling me about? That's the face that he's got. When it comes to manipulating Docker image, first of all, you say, why do I want to do that if it is so complicated? Well, it helps us change the environment variable. So this is important for you to understand. We have the Docker file on the left. These are the building instructions. And then right on the center, we have the already built image. So if we have the thing on the left, the part on the left, we may not need this at all. But our starting point is that the image is fully built, it's fully packaged. Everything is pre-installed on the TARS. That is to say that lots of information has been lost in the phase of stage of building. So on that TAR point, we just want to make modifications in the future execution environment. So what else can we change? We can change the entry point, we can add or modify files and analyze images, for instance, to find flaws, failures, etc. So to manipulate an image, you have to do the following. So you have to work with the manifest. You also have to deal with the reference of it and the actual layer. So this means that any change, even if it's a minor change that you make on a TAR layer, there is a cascade of things that you have to change. And this is what gives sense to everything that we are telling you now. So for instance, if you want to add a new file there, you have to generate a new tar.gz, and that will generate a new hash. And then we will need to update each of these files. And each of these files are referenced to each other. Of course, you can do that manually, therefore that's really, really hard work. Oh, this was not expected. I think this is a copy-paste. Yeah, I know that this is boring. So, attacks. What happens if someone introduces a bug in a layer? Well, it will troyanize our image, but troyanizing an image is not as simple as it may look. Well, one of the images may be this one, troyanized. And what are the implications of troyanizing an image? We are going to do that. We are going to use inject the LD preload to intercept. So every time a binary is executed, we will be launching something. So the process is as follows. Imagine an inks or Apache or whatever is executed, it communicates itself with the libraries when it receives a query from the client. So then the shell is executed. Well, actually, the LD preload is executed, and then a inverse action is open. So I decided to inject LD preload, but I could have injected anything else. So in one of the layers, we are going to modify the environment variable so that it points at one of our library. You know that in Linux, when you do that, the binaries that are executed, the first thing that they do is to upload the library that is used for debugging, etc. In our case, we have made a library. The moment it's built as a builder, it executes a reverse series in a different process, and then the shell is connected, whilst the container goes ahead with its process, with its flow. And we did that, but we could have done something else. And for that, we have created a tool, so you cannot download it right now, not before the end of this presentation. So we just built this tool for testing. So when we execute Docker scan, first of all, we get 3 options. Well, the Discover wanted to show it to you, but we didn't have time to implement it, so forget about it. So because we are now working with the Docker images, these are the things that we can do with a Docker image.
We can extract information and modify it. So let's start step by step. We'll extract information from an image, but first we need an image, of course. How do we do this? There is something we didn't explain correctly. The origin of this talk comes from the fact that one day we were working, and I said, Danny, I'm sure if I do a search for open registries in the world, did we tell everyone about this? Anyway, so we started searching, and we found a lot of open registries. No need for them to be open, by the way. We can be in a development network and capture credentials. Quite an interesting part. The problem is that we can access a registry, and then we can do things. We can download the images, and I'll show you about registries in a minute. Well, the first thing we'll do is to take the public registry, download an image from wherever. So it does the download, but it doesn't execute it. So what do? We get the image and store it onto a file. It exports into .tar. If you do it this way, this is where it is. Nothing else. So we now have the image to play around. Let's extract some information. Take a look at this. It shows information, meta information about the image. The author, well, little things. It can be more or less interesting, but we've got lots of information. I like this option better when we try to analyze the image, looking for URLs pointing at strange places, and we try to deduce the user the image is being run by. This is an image running as root, which is quite common, but it's nonsense. That's crazy. It's quite common that images are run as root. getting the user out of this is really difficult, because this is usually not in the meta information. It might be the user that is running the image, but it's quite common to have a shell script. Within the shell script, you can do a sudo to go down in privileges. So we've done a number of things in order to derive that information, and it works quite well. For certain analysis, it can be quite handy. Especially, it gives you the information when you download the image. It tells you about what you can modify to get hold of whatever you're looking for. Sometimes you modify the entry point and that's enough, or modify the script for the entry point, whatever. So we have 3 commands: change the entry point, change the user. We can escalate privileges down, but we also have the really nice option, which is trojanize. So when we do trojanize, we throw the entire party, okay? Everything goes on. So it goes for the image. Just look, point, and shoot. And then we tell the command where we're going to be listening on the inverted shell. What is the IP? Right, 172, whatever. Don't try to hack me. The port for the inverted shell, and a name for the new container, which is now trojanized. So that's just magic. The new trojanized image is here, and to execute your inverted shell, just do a copy and paste. That's it. That's all we need. We are very obedient. So this is a command. We will not write the IP because we know it. So we stay there listening, and we'll now take the image and load it onto Docker. In theory, you can then upload it to a registry and so on and so forth. But for the time being, to have a controlled environment, let's do it this way. We tell it to load the new container. Take a look at this. This is cool. It is telling you that you have an image, but you're uploading something else, so it will be replaced. So it replaces it with the trojanized option. We now execute this container. What should happen when we execute it? We should see an inverted shell. Connecting people, we're now connected. If we do an LF within the container, look at that. That's so cool and so easy. That means they liked it. He'll now tell you what I started telling you in a random way. I went into panic, so we'll now tell you in a controlled manner. So we've seen the image, and we'll now abuse the Docker registry. We'll do strange things to registries. So there's 20 minutes left because we were late starting today. Anyway, what is a registry? A registry is a system to store images. It indexes images by hash. So using the hashes we saw, it creates a logical structure for the images, which is repository/image ;tag. It uses a GitHub by default, but this is the image, and tag is last. It exposes a REST API to interact. The API is good enough, but it may get very tricky to follow the entire workflow. Deep down, this is an image of a registry. It is something that stores things and indexes them. That's a registry, okay? A place to store images. But this is an essential element in the execution environment for Docker. So how does the registry store the images to start with? It stores the images that we have uploaded, and then it indexes the tags, which are really the versions we want to attach to the different images. If you go for best practices, you should have a latest tag. This is how it matches everything internally, okay? So how about the process to upload an image to a registry? Important detail to take into account. To the left, we have an excited client who wants to upload an image to a registry. I love minions. I just love them. So the client says, I want to upload the image for a minion. The registry says, OK, here is your upload path. What does that mean? That means that when you don't upload directly, you ask the registry to tell you, what URL can I use to upload my content? OK, so it's an intermediate step. And in that path, you do upload the image. Not complicated, but a bit cumbersome, yes? So you upload the image, and there it goes. And then something is generated. A hash is generated associated to that image that only the client knows about. Okay, and last but not least, we tell the registry, well, with that image, you associate the latest tag or whatever tag we're interested in, and that's it. So, cool, everyone happy. But what happens if this last element we don't do? Because this is the client doing it, not the server, okay? An important thing. It is not the server applying the tag. So we show you what would happen if we uploaded files and didn't assign a tag to them. Okay, that can happen. By the way, the Docker client doesn't allow you to do that. It wasn't designed with that in mind. Files uploaded without tags. So we stop this. I have a registry running here. By the way, all of this works with the registry by default. There's hundreds of them. As Alfonso was telling us yesterday, well, there's lots of registries. The original document for Docker tells you execute the registry this way and forget about it. Easy. Obviously, you can go for other options and make it as twisted as you want. Okay, step by step, we have a registry. The first thing we will do, after a Docker P, it's listening on port 5000, which is the default port for registries. In info, it only asks for the location for the registry. It tells us that we are running version 2. That's the address. And it is doing authentication. It does a number of tests to see how you were authenticated in the first place. It would tell you about the remote registry authentication, and it lists the directories. It's a bit dirty because I haven't deleted the information from yesterday. Here we would see all the repositories that we are using, okay? Well, if we want to download or upload, we need to know what there is. So we've extracted some information. What we will do now is simulating what I just said. We'll try to tell Docker scan that we want to upload an image. We want to upload a file. I'm not talking about images, okay? I'm talking about random files. So I'm generating something randomly. Hello, txt. And then I tell it. I give it the URL for the registry. And then I say what we want to upload. So it goes up because it's free. And it gives us a long amount of text. By the way, only you know this. Not even the sysadmin knows about it. Well, the sysadmin could go to the database and find out about this. But unless the Docker is open, it's you and you only that know about this. You cannot get all that information through the API, and there's no way to derive that digest. That digest cannot be derived. Well, there is a way, but not an easy one. Before showing that I can download the image, when we do a process, for example, download an image for me, the registry internally, what does it do with the client? Well, it gives it the repositories, it gives it the image, and then it says, give me the tags. There is a list of tags shown. I have this repo, this tag, give me the digest, give me the hash. This is your hash. And then it says, give me the image for this hash. So it can get quite cumbersome. But if we haven't assigned a tag, how do we get the digest? How do we get the hash? Which is what we've just done. There's no way of getting it. So in order to download this, let's open a browser. This is downloaded now. We open it. The content that we have uploaded. We will do the info thing again, so that you can see there is a long string here. To make it easier for a random name to be generated, you can use a name. You can use your own name, but if you want to keep things simple, this is it. Now, if I did this, if I wrote this, in theory, it should download it. And it tells me there's no references. It cannot download it because there's no references. But if we do it with a really cool tool, which does more complicated things, let's do a delete. We wouldn't be able to do it because there's no reference for this. It asks us about the image that we want to delete. It says, I cannot obtain the tag. There's no way to get that information. And something else which is not on the slides. This is even funnier. By default, when you do this command, you cannot delete images. Even if you could, you cannot delete an image that you upload by default. You would need to use the configuration file. Not only can you upload malware, which is a good thing, the admin cannot delete it because there's no reference, but even if he had a reference, even if the sysadmin had a reference, by default, they cannot delete it. This is quite cool. Not for the registry, but for us, this is so cool. How about a layer on top of it? I mean, I can upload anything, and nothing can be deleted. I'm just imagining things, okay? I'm trying to be wicked. So far, so good. One more slide, and then Robert will finish. And another thing we can do is to take the trojanized image and replace the latest image with it. A short search in Shodan, by the way. The funny thing about this is that whenever you replace, when you have an image called Python dot whatever, you can upload an image using the same name, same tag, and then you overwrite. No one will scream, nothing will happen. The next time they do a Docker pull, they will download whatever image has been overwritten, whatever image is there. The versioning system has to be managed by the client, not by the server. So if you call something with the same name, it is overwritten. That's why trojanization works. Because if we manage to access a registry, we can modify the images there, and all processes using those images will download our image. and the root layer. Are we selling it now? The really cool thing about the demo we just showed is that we modified an image directly. But in a real situation with a big registry, in a company that is using Docker for production, they would probably have several types of images. The images that get modified all the time to add new functionality, and then base images. These are images that are more stable in time. What are we more interested? Well, modifying base images, because these ones have a longer life cycle. When you do a Docker build, replacing an image that is being replaced all the time is not that relevant. So if you modify a base image, on the other hand, all build processes for images that are based on the previous image will be infected, okay? They will have a modified image. So if we infect the base image for Debian, everything coming after that will be infected as a cascade. And the last thing, just to show you the magnitude of this thing, a very short search in Shodan. I don't even know about tags. That's the answer. There's quite a few registries, and we're just scratching the surface. That sounded eerie. It is open to do wicked things. Look at this. And then authentication in registries is just rudimentary. With a Hydra, I mean, you just need less than a second. This is without any effort. You can go there. I see registries everywhere that I can penetrate with no effort. The conclusion is simple. We really need to have security in place. We need some security in Docker environments. What can we do in order to avoid the problems we've just seen? In order to prevent anyone from accessing our registry? It may be someone that got our credentials. It may be an unemployed developer. Anyone that for whatever reason is interested in writing to a registry. What can we do? When we define the images in the Docker files, we can specify the from through name and tag, which is the common practice, or we can use the digest. How about name and tag? Well, because that can be overwritten. We are not referencing a content in a unique way when we're using a name and a tag. The only way to reference something uniquely is by using the digest. If I now modify an image, Ubuntu latest in my registry, and I do a Docker pull Ubuntu latest, I would download the modified image. If in my images I'm careful and I say, no, I build them based on the digest that is based on the latest. Even if someone overwrote that name and that tag, the digest wouldn't add up. It would be a different digest. So Docker build wouldn't work. It would tell us that the image doesn't exist anymore. So our build doesn't work. We will notice that something failed. We will be able to investigate and realize that we need a password. But this is quite obvious. We really need to double-check the integrity of whatever we download, because third parties in between could do lots of things. If we work for an important company, an important organization, we might have third parties modifying the sources of whatever we are downloading. Okay? And talking about securing our registry. Do a Docker run registry is nice, but we really should use, at the very least, some authentication and authorization option. The basic option is not good enough. There are other implementations, private implementations of the registry, that allow us to implement much more robust mechanisms that would allow us to secure the registry more properly. On the same note, we really need to limit the exposure of the registry as much as possible, not just in terms of perimeter security, but also in terms of roles. So in an ideal situation, only the servers that build the images there would be a server that would get the instruction to take code, compile it, and generate the images. Only that builder should be able to upload images to the registry, no one else. Any developer or anybody else shouldn't be able to access the registry. Registry is a core element of the structure. So right permission should be very restricted. And finally, implementing signing. It's been a year, or a few months at least, since quite some time ago, Docker allows to implement signing images. Okay? On top of that manifest that Danny explained, we can add signing information, so that even if we replace the images in registry, because we haven't been able to sign them, because we don't have the keys, our Docker host, when checking the signature, will say, this image is not signed, I'm not executing it. So we would be safe. And finally, if everything fails, we will have runtime protections. The first one, well, this one is very obvious. We said before that if we execute an image that has code that we don't want to execute, we're probably done. We're bust already. What we cannot do by default is to execute images with additional options. There's softwares out there that don't work, so this is not advisable. And to tell you about more advanced securing options, Docker, apart from making our life easier when deploying software, makes our life easier when applying profiles, security profiles, to each process that we run. We could have secoms, Linux, or AppArmor. It is a good idea to have some sort of application that does a profiling of our containers when we deploy them into the production environment and apply a profile. In this case, if our container only gets network connections, we shouldn't allow the container to connect to the internet. And finally, the best option, and the most advanced one in this case, is to use dynamic analysis tools. There are tools, we've mentioned one from our colleague. This is open source and we really like it. There are tools that monitor the behavior of containers. They generate dynamic profiles. Let's show the website. And based on that behavior, they generate those profiles, and if a container changes its behavior overnight, does strange things, invokes syscalls that were not executed before, or tries to access files it didn't access before, or sets up connections that it didn't establish before, we will have an alert telling us that that container is functioning in an improper way. That way, we will be able to detect that someone modified the content in the container. So these are the recommendations to avoid attacks. Remember that there is always someone watching. Questions? In the meantime, I will show you where the tool can be found. Make public. There it goes. There's no documentation because I'm a lazy. Right, it hasn't been documented. As soon as it is made public, you pay for the fine from Amazon or Google or whoever. Yes? These are not registries from Amazon. These are registries in Amazon, hosted by Amazon. The first question, quickly, mine. Can you, is it just as you were able to upload the file and you got it at 256, can you access that file? Will you stay quiet, please? Can you access that resource directly using HTTP? Yes. Right, I just wanted to know that. Yes, the registry can be used as a command center for the infections we want to deploy. Perfect. Questions? I can't see anyone. There's one here. About one of the recommendations, referencing everything with a hash, do you realize that in 3 months you will have obsolete images? Yes, absolutely. I mean, your development cycle with continuous integration has to take into account that the base images are updated. When those base images are updated, because there is a vulnerability or there are incorrect versions, you have to update the hash for the next images. I mean, safety and security can be cumbersome, but in some cases it's absolutely necessary. But obviously it avoids many problems. Someone could do it without noticing it. They might modify an image with contents that we don't want. We know that our root image is working, and that is the digest, and we'll reference that way. So no problems with the operation. In fact, with continuous deployment, the reference shouldn't be touched manually by anyone. The reference should be done in your cycle automatically, so that you don't get into too much trouble whenever you want to update your software. The only way for you to have a safe cycle is to automate as much as possible and minimize human inputs as much as possible as well. So the only human input here should be bit push. Oh, one thing we forgot. We work at BBVA Innovation. We didn't mention that. Our colleague, Antonio, just as Juan Fran said,
So stop it. We just wait for BBA money. Okay. Yes, you're right. Any other questions? Okay. Thank you very much for your interesting presentation about Docker Insight. And as far as I can remember, if you do Dockerfile by adding the file or by making any changes that you want, can you just do the push to the register and to overwrite the tag equally? So what are the advantages of the tool, therefore, that you have created for automated troyanization or to modify images right away from the tar? Well, we just want to create like this button that changes variable, that does everything that it has to do, puts everything in its right place so that you don't have to do it manually. We have not invented anything. So we can do recompilation. So it just makes your life easier. That's it. So would it be a problem adding one more layer with your malicious modification to overwrite in the register? No. You do that internally. You do it, and it does it for you. So I can see that you have not added one more layer, but the result will be the same. Oh, yes, everything that the tool did, we did it before without the tool. So it is more cumbersome, but the tool is there to make your life easier, and it is open to well, it is open. We can add more options to the tool in the future. So, well, my question was very similar to that one. It was about adding one more layer with your tool. Well, we are not adding layers just because when we implemented, we decided to do it like that, and that's it, for no reason. So we could have done it in both ways, and we decided to choose just the first option. We just didn't want it to look that suspicious. So, well, 3 or 4 layers are more suspicious than the layers that we used. What we did is very easy to detect. Actually, if you do reverse, you can see that strange behavior is adding or giving to the container. We are also adding environment variables, so it is very telling, so to speak. You could pass more unnoticed, so that you are not that much detected. You would be modifying binaries in the image with your code. Therefore, the execution would be more silent, and then you would add a library here, there, but you would never add one more layer if you don't want to be detected. But if you control the behavior of the image, you will soon see that the image does different things. All right, no more questions. That's the end of it. Thank you very much for your presentation.
Cuando me he puesto a hablar de